Okay, I wish the Zoom gave you a little countdown about like when it was starting to go ahead and record, but it does not. And so I am already started. And here we go. All right. So before 9:30 and before 10:01, you should be watching this video on graphing linear inequalities, objectives, graph linear inequalities, and graph the intersection or union of two linear inequalities. Homework is a problem set as usual, posted on Math Lab. Lecture will be linked as soon as it is complete. So, part 1, graphing linear inequalities. In order to graph a linear inequality, we simply graph the given equation and then shade in the solution region. So a few hints that won't make sense until after we do the example and you see actually how to do this, but greater than and less than indicate a dashed line. Greater than or equal to and less than or equal to indicate a solid line. And then choose a test point if you are unsure about where your solution region is. So moving right along, graph 2x minus y is less than 6. So let me, my coordinate plane is too big. Let me see if there is a way that I can shrink my screen a little bit so you guys can see the whole thing. There we go, beautiful. All right, so 2x minus y is less than 6. First thing I want to do is graph 2x minus y is less than 6 as a line. Okay, so in order to do that, I'm going to put it in, I'm going to just kind of pretend that my inequality is an equal sign so that I can put my equation into slope-intercept form, find the slope, find the intercept, and then graph the line. So I have 2x minus y is less than 6. So again, I want my y equals on one side. So I'm going to add y to the other side and subtract 6. So then I get 2x minus 6 is less than y. And remember, when you're doing these, that you have to flip inequalities when you divide by a negative. So remember that can get tricky. We didn't divide by any negatives, we were just adding and subtracting. So our equation can stay like this. And then if it even makes more sense for you, you can write y is greater than 2x minus 6. So those are equivalent statements because look, my inequality is facing my y, and then when I put my y in front, it's still facing my y. So we're good there. And now I can see, okay, my y-intercept is negative 6. So I'm going to put a point down at negative 6. 1, 2, 3, 4, 5, 6. I'm going to put a nice little dot there, so hopefully everyone can see that. And then I know that my slope is going to be 2. So I'm going to count 2 over 1, and that's 2 over 1, 2 over 1, 2 over 1, 2 over 1. I'm just going to really keep going with this guy all the way over there and then all the way down. Okay, then I'm going to remember my handy little hint that said greater than or less than is a dashed line. So I'm going to make a dashed line instead of a solid one because dashed line indicates that it cannot equal any point on that line. Solid line would say, okay, it's all right if it equals this. Our inequality says it's not okay if it equals this. So we draw a nice little dashed line. And then the last thing we do is we figure out a solution region. And there are a couple ways you can do this. The way that I kind of do it is I think about, okay, greater than is on top and less than is on bottom. So my solution region is going to be on top since it's greater than, and so it's going to be on top of my line, which is this. These are kind of fun because you get to color. So we color in our solution areas. So this would be the example to this problem. Graph 2x minus y is less than 6. There's my example. Another way that you can figure out which one is your solution region, like the top one or the bottom one, or maybe that just confuses you and you see it as more left, right, and you're just like, what the heck, Miss Youngam? Is you can pick a point. So I'm going to pick the origin. So I'm going to pick 0, 0. And you have to pick a point that's very clearly on the left side of the line or the right side of the line, right? So I'm not going to pick a point on my line, and 0, 0 is not on my line, so I'm good there. So then I'm going to plug that in. So if I plug in 0, 0, I have 2 times 0 minus 0 is less than 6. And then you just want to see if your inequality becomes a true statement. So 2 times 0 is 0, 0 minus 0 is 0. So I'm going to have 0 is less than 6. That is, in fact, a true statement. So I know that my point that I chose is within my solution region, and therefore my solution region must be up here. If I had picked a point down here, my inequality would not be true, which would lead me to know, okay, it's the other part. So you can pick a point to help you determine, okay, where is my solution region? So that's literally it for graphing inequalities. Just graph the line and then figure out, okay, where's my solution region? So that is it on graphing inequalities. The next quick thing we're going to do is graph intersections. So graph the intersection of two linear inequalities. So let's look at our example. We have graph the intersection of x is less than or equal to 1 and y is less than or equal to 2x minus 1. So first thing we have is x is less than or equal to 1. When we have x is less than or equal to 1, we know that we're dealing with some kind of line that's like x equals, which means we have, hopefully you know which type, vertical. Yes, we have a vertical line at x equals 1, and my inequality indicates that I get to have it, that I'm going to have a solid line as well. So at x equals 1, I'm going to have a solid line. And then it's not an equal sign, so I have to think about my inequality as greater than or less than. So this one makes it more obvious about, okay, I'm going to pick a point over here. I'm going to pick, what is that? That's 4, 0. This one you can't really think about top or bottom, so you have to pick a point to figure out where your solution region is. So I'm going to pick 4, 0, and then if I plug in 4, 4 is greater than or equal to 1. True statement. So that means that this is a solution region for my top inequality. So that's my top inequality. X is greater than or equal to 1. Now I'm going to think about my second inequality. Y is, why did that erase? That is the question. Y is greater than or equal to 2x minus 1. So this one is already in a nice form. So we know right off the bat, y-intercept of -1. Slope of 2. Oh, this is the same problem that we just did. That's funny. So 2 over 1, 2 over 1, then I go down here 1. My inequality says, oh, it's not the same because my inequality says solid line. So I can sketch that nice solid line. And then I know that my solution area is going to be on top of that line. So I know my solution area is going to be here. When we graph the intersection, our final answer is the area where the two solution regions overlap. So final solution is going to be in red. Final solution. Well, my two areas overlap right in this little triangle. So my final answer is going to be that little triangle. And that is graphing intersections. Basically, you just graph both of your inequalities and then you see where do they line up. That's going to be my solution. So, yeah, that is graphing linear inequalities. Not too shabby as long as you remember a few things. And if you have questions, bring them to class. And I'm going to end this video so you don't have a lot of lecture to watch. Oh, end.